When I took a slow motion video inside my house, I noticed this tube light flickering. Is this a camera problem? No, because if I take the same slow motion video outside in sunlight, I don't see any flickering. So clearly the tube light must be flickering for some reason, but why? To answer this question in this video, we will explore the two different kinds of electric current. And so current comes in two flavors. One is called the DC, which stands for direct current. And then the other one is called AC, which stands for alternating current. Alternating current. So what's the difference between them? Direct current is a one directional current, meaning you can imagine the current just flows in one direction. If you could visualize the electrons inside this wire, then you can kind of visualize them as, when the current starts, electrons start moving, they're moving in the same direction with the same speed, one particular direction, like this. Okay, and since the current value is the same all the time, we will see that the bulb keeps glowing with the same amount of brightness constantly all the time. One directional current, DC. Your batteries usually provide this kind of current. Okay, what about alternating current? Well, this is where the current keeps changing its direction continuously. Once the current would flow this way, then the current would change and flow the opposite direction. Then again, it'll go back and forth, back and forth. Again, if you could visualize the electrons over here, now you would see the current is going, the electrons are going back and forth, like this. All right, but why does that make our bulb flicker? Why does that happen? Well, let's look at these electrons a little bit carefully, and let's do it in slow motion now. As the electrons are going forward, notice when it's about time to change the direction, they first come to a stop and then change the direction. They go back and again go to a stop and then change the direction, go forward, stop, backward, stop, forward, stop, and so on. Every time the current stops, electron stops, the current goes to zero. And when the current goes to zero, the filament over here cools down a little bit. And when the filament cools down a little bit, the bulb dims a little bit. Why doesn't the bulb completely switch off when the current goes to zero? Well, that's because, as you can see, the current comes back up very quickly. So it stops only for a fraction of a second. And so during that fraction, the bulb cools down just a little bit and then again heats up, cools down and heats up, cools down and heats up. And that's why we see the bulb flickering like this. And why do you think it flickers 100 times a second? Well, that's because it turns out in India, the current that we get from our main supply changes its direction 100 times a second. So let me just write that down. That seems important. So the current changes direction. Let me just write the current changes direction about 100 times per second. All right. And that means the current goes to zero 100 times in 1 second. And therefore, when the current goes to zero, that means our filament will cool down about 100 times a second. And as a result, we'll see the bulb dimming and then coming back up about 100 times a second. And of course, something very similar is happening with the tube light. It's flickering because of the alternating current. All right. This might bring now more questions to your mind, like why do we choose 100 times a second? Or why do we even use alternating current in the first place? Right? We'll address these questions towards the end of the video. But let me quickly first talk about the standard way of representing how quickly the current changes its direction. The standard way of doing that is by coming up with a number called frequency. What does the frequency represent? It's representing the same thing a little different way. Instead of talking about the number of times the current changes its direction, it talks about the number of times or number of cycles the current goes through per second. So number of cycles per second. It turns out that there is an advantage of doing it this way because when we look into the mathematics of this, it turns out that this is a very nice number to use in our formulae. So what is the meaning of the word cycle over here? So whenever things are going back and forth, their motion is repeating itself. That particular motion which starts repeating is what we call a cycle. Let me be more specific. So let's bring back our electron. We know the electrons is going back and forth, so it goes forward, then changes direction, goes back, changes direction again, goes forward, and so on and so forth, right? This is what our electron is doing. Now notice, once it has gone forward and then comes back, and once it changes direction, then the motion repeats itself. It's the same as before. Again, goes back and changes direction, motion repeats itself. Therefore, since the motion repeats after over here, after it has changes direction, we will say this is one cycle. Does that make sense? This is one cycle. So cycle is the portion which starts repeating itself. And after this, again, the next cycle begins. And then once the electron comes back and changes its direction, that cycle ends and the next cycle begins. So this is cycle number 2, and then this is cycle number 3. And the frequency basically represents how many cycles is this electron going through every second. Now, here's the question. Given that we know electron changes direction 100 times in 1 second, can we figure out how many cycles it is going through in 1 second? These numbers are related to each other. Can you pause the video and think about this? All right, hopefully you've tried. Since I know the total number of times the electron changes direction in 1 second, what we can do to figure out the frequency is, let's see how many times the electron changes direction in 1 cycle. Okay, so let's look at the first cycle. Electron is going forward and then whoop, changes its direction over here. So the electron changes direction over here once, and then it comes back, finishes. No, it finishes its cycle when it changes its direction again. All right, why? Because notice next cycle cannot begin unless you change your direction. So the electron finishes its cycle, the first cycle, after changing its direction again. So it changes direction once, it changes direction second time. So in 1 cycle, the electron is changing its direction 2 times. That's important. Same case with the second cycle as well. Goes forward, whoop, changes its direction, goes back, changes direction, and gets ready for the next cycle. Then goes forward, changes direction, goes back, changes direction. So in 1 cycle, the electron is changing its direction 2 times. So let's write that. 1 cycle, the electron changes direction 2 times. So if the electron changes direction 100 times, how many cycles is it? Well, notice the cycle is half of the number of times it changes direction, right? So if this is 100, if the electron is changing its direction 100 times, then that means how many cycles must it be? It has to be 100 by 2, 50 cycles. 50 cycles. And so in this case, we will say the frequency is 50 cycles per second. Let's write that over here, 50 cycles per second. And cycles per second is also often called hertz, named after the scientist Heinrich Hertz. And so notice if the current is changing its direction, or if the current goes to 0 100 times per second, that means the frequency is half of that, 50 hertz. And since this is the standard chosen in India, this is the Indian standard, that means everywhere in India, we get about 50 hertz frequency of alternating current. This is an Indian standard. In United States, this number is about 120 times per second, which means the frequency would be half of that, 60 hertz in the United States. All right, that's pretty much it. Now let's come back to some of the curious questions that you might have before we end the video. One question you might be wondering is, why 100 times a second? Why not any other number? Well, if the number is too low, let's say it was like 2 or 3 times per second, then the flickering would be very obvious to us, right? And in that case, it will be very inconvenient, so it can't be too low. And turns out if you make it very high, then there are some other problems that start coming. And that's why it needs to be high enough, but not too high. And that's why it's about 100 in India or about 120 in the United States. Another question, last question we will tackle is, you may be wondering, why even go for alternating current in the first place? Why can't we just go with direct current? What's the problem with that? That's actually a very interesting question, because it turns out it's got something to do with efficiency of power transfer. So let's look at that in a little bit detail. So here is, let's say, your power station through which the electricity is coming from the electric poles to your houses. Now, since the power station is very, very far away, that means the electricity has to travel a long, long distance. And since we have lots and lots of houses, the electric current required will be very high. So that means these transmission cables would have to carry a lot of current. They'll have to carry a lot of current. Now the problem with carrying a lot of current in the transmission wire is that it heats up the wire and it causes a lot of heating. Heating is loss of energy, and that electrical energy is getting converted to heat. That means most of the the electricity is being wasted as heat. Who's gonna pay for that? You, me, or the electric company? It's gonna be bad. It's gonna be a very, very inefficient thing. We can't do business over there. That's why we go for alternating current, not direct current. Now you might say, how does alternating current solve this problem? Well, when you're using alternating current, what we do is we send very low amount of current through these wires, very low amount of current, okay? And therefore the heating losses will be very low, and that solves our problem. Well, of course, now you might say, okay, if you send low current, then how will we light up our houses? Well, that's where something called a transformer comes in. You may have heard of this. We'll not look into details, but what a transformer does is it takes in that low amount of current and then it increases and gives you a high current. That's the specialty of a transformer. It's not magic, of course, it's science. We need to understand how the transformers work and everything, which we'll do in videos of higher grades. But as of now, just remember, just think of it this way. The transformer can take in very low current and convert it into a very high current. This way, we can save a lot of power loss. Now, the main thing over here is that transformers only work on alternating current. So you can only use this trick with alternating current and not the direct current. And that's the main reason why we supply alternating current, because we can do it at a very low current, and that gives us very low power loss. All right, that's pretty much it. So let's see if we can go ahead and summarize and recall what we learned. First thing, can you recall what AC and DC stand for and what exactly are they? What's the difference between them? Secondly, what is the meaning of the word frequency? What does it mean to say frequency is 50 Hertz? Can you more importantly explain why? If frequency is 50 Hertz, that means that the current is changing its direction 100 times per second. Okay, try to explain this, say, to your friend or to someone in your family. It's a super important concept over here. Finally, can you now explain why we go for AC when it comes to power transmission to all our houses and not DC? If you have difficulties answering these questions, no worries. Feel free to go back and rewatch that part of the video.